I think we're ready, gentlemen.
Okay, you're on.
We are on. Hey, everybody, welcome aboard the SBAU Astro Hour. SBAU stands for Santa Barbara Astronomical Unit, everybody. That's the Longtime Telescope and Astrophysics Club for Santa Barbara, California, which just happens to be the county seat of America's West Coast spaceport. I am Ronnie Herron, your proud host, and these distinguished gentlemen around me on the screen will be leading me and you through these topics this week. Got the weekly planetary roundup in the night sky. Even got a comet to talk about called, what is it, 3I slash Atlas. M1 is called the SBAU. I'm starting to search the crab SBAU. I can't read my writing. It looks more like a baby's high chair after dinner, but it's called the crab. Aquila, or is it Aquila, the eagle constellation? I guess it's Aquila, flying high with an open cluster, NGC 6709 inside. We're going to talk B stars, shell stars, and comparisons of red giants to our sun. Asteroid 4 Vesta is easy to spot in Libra these nights. How many globular clusters do you think there are in our companion galaxy, Andromeda? We're going to tell you this hour. And yet another galaxy, the Webb telescope may have captured the birth of a black hole. Not much moonlight to interfere with falling stars, seeing them anyway, from the southern delta Aquariid meteor shower. We meet at the Museum of Natural History in Santa Barbara every week. In fact, this Friday night, Dr. Kane from UC Riverside takes us planet by planet, see what the habitability of exoplanets might be. And then the second Saturday, we meet at the museum at night for our star party. Let's meet the gang. Our commander-in-chief of the starship with the weekly talking points makes him sort of like a UCSB professor, and he runs the show. Beloved President Jerry Wilson, hiya, my
Good
friend.
morning. And good
How's your
morning,
wife?
Joyce.
Yeah, gentlemen. Pat Forgy, he's married too, and she supports us, probably in the background, like Chuck Partland, our outreach guy, in front of the Ukraine flag, and his wife, Pat, is merchandise manager and an overworked treasurer. We have Tom Whittemore, who
Morning.
is our editor. Hi, Tom, retired
Morning.
from Westmont College, and really has a lot of friends because he smells like baked bread everywhere he goes. Married to Maureen, who used to take my blood samples years ago in the anticoagulation clinic. And there's Tim Crawford, who'll be featured in the newsletter. Tim, uh,
Hello.
married to the Karen. Are you going to be on board tomorrow night's workshop? That's every week, isn't it? The
Yeah,
workshop too.
I probably will be. Yes, yes.
All right, and then we're going to read about you in the newsletter being compiled as we speak by Mr. Tom, former professor. We got
Yep.
silly
Don't miss
stuff.
it. Don't miss it. Don't miss it. A very famous article.
Yeah.
Okay, I was published in there once too, a couple of years ago. He kept it for a few months, but apparently Jerry comes through with incredible little articles,
Right.
and then we put the rebuttals from Michio Kaku in the following. Never mind, shut up. We got stupid stuff, silly cartoons to look at, some of which we haven't been seen, but we start the program with a little levity. And I haven't seen this one. It's a teacher in the class with 3+2 on the screen. She says, "Do we need this, even if we're not planning to go to college?"
No, the
Oh,
little
the
boy
kid says
says
that.
that.
A
The little
kid
boy
says that.
says, yeah.
What? Okay, great. I got
No,
it.
the little boy in the chair says that.
I know that. I just realized that looking at it.
Oh, yeah.
Okay, three. Do we need this? Yeah. English class is closed down everywhere. Boy, nobody can write. Here is the leopard frog. You want to do this one, Jerry? Tell us what we're looking at.
Leopard frog, Rana in honor of those who met their fate at the hands of an untold number of biology students.
Yeah,
I
but the
don't know if
legs
they
are,
still do that or not, but when I took ninth grade biology, we dissected frogs.
yeah, but the bright side, you could go home and have legs like you wouldn't believe. They were delicious.
Well, one of the girls in our class threw the frog out the second story window and said, "Run for it."
Did she really?
Yeah.
Are there some similarities between a frog and us? Or are we just trying to get, they're not even mammals.
She was empathetic to frogs.
Okay, this one I haven't seen. Where are we? Rhetorical questions? We're at a
This is a,
kiosk.
yeah, this is a train station, I guess, the information booth. If you have questions, and here's one dedicated to rhetorical questions.
You love those. Okay.
This one is from your,
My friend Joe Daly, who used to
yeah.
have the alternate program about aviation, who would alternate with our hour of astronomy every other week on Mondays when we were on the radio years ago. He's listening right now. He's tuned in. I think we've hooked him. All right. What you want me to read it or you want me you
Go,
want to
go ahead.
All right, the physics professor is at the blackboard telling him, along with antimatter and dark matter, we've recently discovered the existence of doesn't matter, which appears to have no effect on the universe whatsoever.
A classic.
Yeah, that came from Joe Danley. How you doing, Joe? He's
Thank
one of
you,
my
Joe.
lunch mates on Thursdays at the Farmer Boy. Oh, here we have Hobbes and Calvin. You want to do it, Jerry, since you sent
Uh,
it and I haven't seen it?
yeah, Hobbes is there. They both at the same time say a UFO. And these creatures come out and say, take us to supreme earthling potentate. And he goes, well, and then he goes, speaking, oh, what luck. It was I who chose the landing site. Kudos for Navigator Nebular. This is
You know
Calvin
what that
flipping into one of his daydreams.
you know what that cartoon reminds me of?
What?
The ending of one of the Twilight Zones when the people are going on board the ship and there's a book they
Yeah.
wrote called To Serve Man.
Oh,
Yeah,
yeah.
it's
Remember
a
that?
cookbook. It's a
It's a cook.
cookbook.
That's
Yeah.
right. Okay.
Our friend Astro Deli is with us again, and he says he can't always get here because I guess of school, but
Ask him
or
ask
what?
him what ask him what time it is in India right now. It's
Well,
gotta
you're
be
asking him right now. It's I think it's about midnight. So
he's out with his telescope then. All right. Where are we on this one? You're gonna have to guide us through, Mr. President. I haven't seen
Okay,
it.
it says there's guys looking in the door, and the woman is whispering to him, says, what we especially like about these theoretical types is that they don't tie up thousands of dollars worth of equipment.
Okay. Give me a minute and I'll get it. What something keeps popping up on it, but it's gone now. Okay. Fantastic. We're not going to do the legs on the dolphin one, are we? That was
No, we didn't. No.
okay. Okay. I'm feeling looser and lighter and ready to cruise the cosmos with you guys. You did send an amazing picture, though, showing three ghosts of former astronauts trying to put the flag up on the moon like Iwo Jima. Did you remember that?
Yes.
It wasn't funny, but it was awesome looking.
Yeah.
Actually, it was four.
Well, the fourth was alive. The three that were the guys that
They've all passed.
Yeah.
Mhm.
oh, they've all passed, including well, Chaffee was the only one I didn't know. Grissom died in what was it, Apollo 3 or Apollo
Apollo
4?
1.
Apollo 1, that's the one that I don't think that
Caught
was a
fire
later.
inside.
There was a burn, yeah.
Yeah.
That was the first one. Wow. Okay. Back to the night sky we go, everybody.
Okay, this is the dawn sky. Still night, technically 5 a.m.
All right.
And this is showing the planets. This is part of the planetary roundup. This is showing the planets, Jupiter, Venus, and M1 in the dawn sky tomorrow morning. But it doesn't make any difference tonight. This morning was about the same.
Mhm.
So we can see the winter constellations for this coming winter just starting to enter the sky here, Orion, with some of the brightest stars in the sky. Up here is M1 somewhere.
Farther down, between the horns.
Oh, you're right. There it is. Yeah.
Mhm.
I was worried. Sometimes I put it outside. But anyway, there's M1 down here near Venus and Jupiter. Venus is getting about as high as it'll get, and then it'll retrograde back down here.
Mhm.
Jupiter will continue rising throughout the year until it sets in the west in the evening.
Mhm.
And this is the Milky Way going up in here. The little cutoff is the way the planetarium software puts itself together. So anyway,
I got
Mercury.
I got a
Go ahead.
quick question. I understand I could hook this computer of mine, my little laptop, to my big screen TV for YouTube stuff. Would I be able to do that with this? I think it'd be incredible to see that night sky on my giant TV screen. Do any of you do that?
You can do it.
But you guys don't, right?
The
I
TV
don't.
resolution usually isn't quite as good as your screen,
Yeah.
but it would be bigger.
Yeah.
Okay.
I
I
have
can
my
barely,
brand new laptop. Looks great.
I can barely
I
read the
lo-
words. Okay.
Well, if there's anything you want to read, let me know and I'll blow it up. So, or anyway, Mercury is out of sight and it's in conjunction with the sun. Venus, of course, is here as a morning object. Jupiter also. Oops. And this is in the evening, 8 o'clock in the evening sky, tracking down some more of the planets. Here is the moon tomorrow evening at 8 o'clock. It's a young crescent, waxing crescent. And it shows Mars here, which is in Leo and Virgo. It's Virgo up here, and it's leaving the hind legs of Leo. And here is the Virgo cluster up here, setting. So we'll have a really good view of that again next spring, about next March. Saturn is not in here.
It's an evening sky now.
This is
It
this
rises
is an
before
evening
11.
sky. Right. So this is where Saturn is now. This is 3 a.m. So it rises, like you say, around midnight, around 11. Here's Saturn and Neptune. And then down here is Uranus. And I didn't show Pluto because they don't show Pluto on astronomy's roundup.
That's an
But
evening sky
if I
anyway.
can, yeah. And what else was there around here? Oh, yeah, Uranus is down near the Pleiades. We'll get to the Pleiades in a little bit on another topic. And then Comet 3I Atlas, taken by Hubble.
Mm.
And you can see that it does have a haze, nucleus, coma, and a bit of a tail, probably pointing more away from us than longitudinally.
Suppose
So
the tail's
it's
going away.
moving right along, 150,000 miles an hour. It isn't going to stay around in our solar system.
Screaming in.
This one it is now estimated because we have, with the Hubble, we have spectroscopic data from it. And it is estimated to be 4.6 billion years. Oh, no, that's our Milky Way system. I mean, our solar system. It's estimated to be 7 billion years old.
Hmm.
And
I'm
what's that?
confused, Jerry. Are we looking at the comet or the interstellar thing passing through? You said 150,000 miles an hour.
It's an interstellar comet, Ron.
Oh, it's a comet that's passing
Yeah,
through?
Yes.
yeah.
That's what 3I Atlas is. Oh, I
Yeah.
thought it was a regular comet
It
from
is a
our.
regular comet.
Well, I know, but
Yeah.
most of ours come from the Oort cloud or the Kuiper belt, I would think.
Yeah.
Not this one. This is from beyond.
I'll be
There was
damned.
a TV show called that.
Did you know that, Tim?
That's why it's got the I in there for
Oh.
interstellar.
Okay, so it's like a Oumuamua came through and it wasn't a comet
Yes,
because
it was.
it was a comet?
Yes.
It just
It had
wasn't
a
real
tail?
dramatic like this one's going to be.
I missed it, Ronnie. I was looking. We have another fellow. I think it's Mia's dad, Richard, that we see out there at Westmont. So, what was it? What was it that I didn't know about the
The
comet?
comet, did you know it was the interstellar thing passing through?
Oh, there was something about that in the talking points, and I thought it was
Well,
interesting.
it was just talked about on the air. Well, we
Oh,
got at
sorry.
least 3 people watching us, Joe and this new person and our friend in India.
The path and the speed of this object, whatever it is inconsistent with a closed orbit. So it is on an open orbit called a hyperbola, and it is not going to stay in our solar system. It's just zipping through.
Well, it could be
Most
an
of the
Astro.
things in our solar system are 30 to 70 thousand miles an hour. This one's 150 miles an hour. So it's beyond the escape velocity of our solar system. And that's
That's
what
what
it's
I
going to do. It's going to
that's what I
escape.
remember from the talking points.
But the
Okay.
Oumuamua didn't have a
So
tail. I
if I
don't.
disappear, I'll.
Sorry.
Okay, my computer says my connection is unstable. So if I disappear, you guys carry on, and I will take some time to get back in. But anyway, this
Oumuamua
has
was also an icy body, Ron. It was composed apparently of a lot of stuff like hydrogen ice that doesn't leave a nice visible tail.
All I remember was the cigar shape. I had no idea it had steam coming off of it.
Well, it was also compatible with a shape that looks like the Millennium Falcon, so a lot of people like that.
Yeah.
yeah.
You can get on board the Oumuamua at
But
Disneyland.
anyway,
then.
the Oumuamua made an orbit change while it went through, which was attributed to gas jets being excited by the sun, except
mean
for
above
Avi
it?
Loeb, who has a possibility to discuss possibilities, not probabilities.
Above and beyond the
So
orbit.
anyway, this
Okay.
because of the Hubble taking spectra of it, it has abundant water ice, and it is composition has a dust composition similar to a D-type asteroid, and more than that, more to a D-type asteroid than to an ultra red trans-Neptunian object. Yeah, D-type asteroids are space rocks packed with organic molecule-rich silicates and carbon with water ice in their interiors. So if we could get a sample of it, it would be a very interesting object. It was created before our solar system came into being.
Whoa. So we'll say goodbye to it, what, in a
Any other
year?
comments?
Yeah, it's screaming through. It's going to be closest
Okay, this
in
is the
October.
Crab Nebula.
October it'll be close. There it is. Got to clean that mess up.
Yeah, it's a little bit blown out.
Okay,
Reminds me of the drunk outside my house that had a pizza one night. Never mind.
That's pretty crude.
I know. What we're all about, isn't it? Yeah.
Yeah.
Aha.
better? No?
There we go. Yeah, that's much better.
This was really nice.
That's
Okay,
a crab, huh?
this is the Crab in visible light. It's taken by Hester and A. Lowell of Arizona State University.
Hmm.
And it is very nice. You can take pictures of a picture like this, and you can compare it to similar pictures taken with the Mount Wilson telescope in the early 20th century, and you can see the growth and change of these filaments. It's basically a puff of smoke. So to oversimplify it, this
One
is the
star.
core. Go
Okay.
ahead.
I was just curious. Crab is the remains of one star that exploded. Do they know how many years ago?
July 4th, 1054 AD.
Really? That's all it is.
Yep.
1,000 years, a millennium.
It was visible in the daytime for weeks. People kept track of it.
And it's gotten that big. Is it going to continue to, will it collapse back or
No,
spawn new stars?
it'll
Okay,
continue to expand.
got it. Where are we now, Mr.
Okay.
President?
Yes.
This is like a higher energy view.
Mhm.
Oh, this is the same one. This is still crab?
Yeah.
This is the core of the crab. This is taken with the Hubble telescope, and it's part of a video showing the wisps of energy pulsing out of it from the remnants of the rotating neutron star in the middle. Let's see if I have a picture. This is a picture from the video. I'll see if I can get that up here.
Really? Make it
Didn't
move?
prepare this.
Oh, it
Yeah.
What's
doesn't.
that?
Yeah, as it pulses, you can see these little lines move outward from the pulsar.
Really?
Yeah. And there were
I-
some guys, some amateurs that had a large scope, and they actually put a little rotating disc with an aperture in front of the eyepiece, and they synced it up with the pulsar by changing its rotation rate, and it actually they could basically detect the pulsation of the pulsar with that.
We can't see it, but it's there in the middle. That's all that's left in the
Well, you can
center.
see it
A
if you got a
pulsar?
big enough scope. I mean, and there it is right there, the sort of blobby one right under those discs.
But this looks wider than it is high. Are we looking at an angle? Is it
Yeah. Yeah, we're just
angled away
zooming
from us?
in.
Okay, got it. Hmm, M1. So that was the first one old man Messier discovered, I guess.
The first in his catalog, yeah.
Bear
Here we
with
are.
me, I'm almost back.
You okay, Jerry?
Um, yeah, stop share. Okay,
Uh,
share.
Suppose if any of us,
one comment on this, final comment on the crab is that we, with our scopes, for outreach scopes, the crab
There it
is
is.
just a kind of a little tiny blob of
Yeah,
Kind of
splash.
football shaped.
Yeah,
I'm
splash
curious
of
as if
milk.
the sea stars would
Can you
get a
see this?
better image.
moving.
Yes, we can see it and it's animated.
Can you see this video?
Yes.
Yeah.
Mhm.
Okay.
Well, is that speeded up? Is that over millions of thousands
Well,
of years?
it's not real time. It's a series of about 5 or 6 frames, and you can see the date each frame was taken.
Mhm.
Oh, I see. There it is. Yeah, you're right.
So this was in
I heard you.
2005.
That's how you get movement in space.
It's September to November.
Wow. Well, it certainly doesn't look like the remains of a pizza on a sidewalk anymore.
I mean,
But love our crab. How far away is that sucker?
It's like
Maybe
5,000 light years.
5,000. But they did see it 1,000 years ago.
Yeah.
Mhm.
Did it daytime
Yep.
really lit up the sky, didn't it? For several nights, weeks, months, years?
I
How
think it was
long?
weeks.
Weeks. We're supposed to get
Mainly
a
the Chinese that kept track of it, and also potentially some of the like Anasazi tribes in the southwestern US have records of it.
Mhm.
Is that right?
Mhm.
We're supposed to get one a year, or is it one every 100 years?
100.
Is it 100 years? You get a
Yeah.
star blowing up. All right,
In a given galaxy.
including us. Okay,
can you
there's
see
my.
this?
On any given evening, you can find hundreds of supernovae if you just
Hey, you
have a
got
big
my.
enough telescope.
Reminds me of the thumbprint I had
Yeah,
to
with
leave at the
one
police
big enough
station.
telescope.
Look at that.
Okay, that tells me you can see it. This is the first drawing by Lord Rosse through his 6-foot diameter telescope in Ireland in the 1840s. And this is where it got the name the crab, because the other pictures, the more modern pictures, don't remind me of a crab. This doesn't either. Reminds
Like
me more of a
looks more like an obese
bug.
lobster.
Yeah, something like that. Yeah.
Huh.
So anyway,
But you can see that kind of football shape. That's what you mainly see in a backyard telescope.
yeah.
But it was only 700 years old back then, wasn't it? Or 700 or 800 years since it
Well,
happened.
this is 1840s, 1850s.
Oh, okay. So it's gotten a little bigger since then.
So it was about 800 years.
So we put
Okay.
little black dots in.
So
Aha.
we're going to look at NGC 6709, and I thought I'd give you a little stats on it instead of just
Sure.
reading it. because there will be tests later, so you need to be taking notes.
Let me get my
So
note.
this is in the Eagle Nebula.
Huh?
So its magnitude, the object is a magnitude 6.7, which is
Right.
means that you just might pick it up with averted vision with a naked eye if you're standing up on Mount Mauna Kea in the
Yeah.
Hawaiian Islands or some super dark place. But you
And there's
won't
no
normally
moon.
see it. You what?
And there's no moon.
Yeah, no moon.
The
So
other
it's
night
not-
I was, you know, when I do the asteroid occultations, I take a sky quality meter reading. And the other night I was up, can't remember where I was, but it was 6.3. It was a really good night.
This NGC we're looking at here was
No.
No, you're looking at the statistics on it, or the information sheet. It spans 13 minutes of an arc, so it's not negligibly small. You can see it in a 4-inch telescope, for example, minimum. So it's situated toward the center of our galaxy at a distance of 3,500 light years from us. This cluster
Wow.
has a Trumpler class 42M and is considered moderately rich with 305 stellar stars in the cluster. It's around 141 million years old and about the same as the Pleiades. The core radius is 2.2 light years. So if we were in this star cluster, it would stretch out to partway to our nearest star, Alpha Centauri. It has two BE stars. One of them is a shell star, and it has one candidate red giant member. And it turns out on the evening of November 13, 1984, David Levy discovered his first comet less than a degree from this cluster. Little bit of trivia.
Can you?
Now, you might well be wondering, what is a BE star? This is a B-type star, and you remember the classification of stars shows their surface temperature. This is B, it's a hot star, and it's got an emission line in it. That's what the little E stands for. So it's a B star with emission lines. So, and the emission lines are typically the Balmer series of hydrogen. It also contains a shell star, and a shell star is a star that has several features. It has a spectrum that shows extremely broad absorption lines. Broad absorption lines can mean high speed. They're Doppler shifted to be broad. It shows very narrow absorption bands, very narrow absorption lines also, and some emission lines, usually again from the Balmer series. These are due to rapid rotation of the photosphere, but not the whole star. This is due to emission lines from the equatorial disk, and the narrow emission lines are produced by when the disk is seen nearly edge on. So there's a lot of features that have been deconvolved about these stars to figure out what their structure is. A red giant star is, what's that?
I'm curious about emission lines. Is it something we see?
Yeah.
Yeah, go ahead.
It's a brighter part of the spectrum, whereas the absorption lines are where there's a darker part of the spectrum.
Okay, got it.
So in order to have an emission line, you have to have an atom. And that means that an electron has fallen from an excited state to a lower state. And in doing so, it has given off a photon, and that's what we see. And that's emitted a photon. So it's an emission line. And it shows up as a bright line, as Chuck says. An absorption line is where for example, our sun does not have any atoms in it. It's a plasma. It's all the atoms ripped apart. But in the atmosphere above the sun, atoms are forming. And when they form, they absorb the light from the body of the sun, and the electrons get excited up to a higher level by absorbing some of the sun's photons before it's sent to Earth. And we see those as a black line. So those are absorption lines. A red giant, you all know what a red giant is. It's a big star like our sun is going to be. And because it's red, it's cooler. It's about 5,000 Kelvin. and our sun is about 5,800 Kelvin. It's a yellow star, yellow-white.
Can I give you a question from the YouTube side?
Yeah,
Sure.
It is how do quantified photons account the variations of light emanating from shell stars?
I don't understand the question.
Yeah, and then the follow-up here is I don't understand how you say stars don't have atoms in them.
Because the star is made out of a plasma. It's got all the parts of an atom. And when we talk about burning hydrogen and converting it into helium, we're not talking about the atoms, we're talking about the nuclei. So
Okay.
it's playing games with nuclear chemistry.
Yeah, the electrons have been ripped off, so it's not an atom.
This is from our friend Richard that we see out at Westmont, Chuck, Mia's dad.
Okay.
So anyway, we'll keep
Tell
on
him to
going.
drop by next time. We'll chat.
Yeah, yeah.
Okay, Trumpler class. I slipped that one by you. This was from a Swiss American astronomer, Robert Julius Trumpler. And he had 4 categorizations. The degree of concentration was from Roman numeral 1 to numeral 4, which went from tight to hard to see boundaries, from real tight ones, almost globular, to hard to see boundaries. That is, you can't really tell it from the background stars real easily. It also has a number from 1 to 3 that gives the range of magnitudes in the stars found in the cluster. So this is from a wide variation at 1 to 3, where all the stars are roughly the same magnitude. A number of stars in the cluster, P is less than 50, M is 50 to 100, R is more than 100, and if there's an N attached to it, it means that there's a nebulosity involved. So Pleiades would have an N after it. This classification was developed in the early 20th century visually, and it is still used today. Now, back to everything else from here on is pictures, so don't panic. Okay,
I'm just
this
panicking about the
is
test coming. On what you just said, Jerry, I'm panicking about how I'm going to do
where
it.
NGC.
Wow.
I think my connection is poor.
Well, we just lost Ron.
I see that. Yeah,
Oh, here he
I
comes.
hope I'm coming. I hope I'm coming back. There I
Yeah,
am.
there you
back.
are.
You're back. Okay,
Hmm.
this is where that cluster is located. NGC 6709. And over here, and we have a number of interesting objects up in it too, or not in it, but near. We have 2 Pallas up here. Down here, we have 5 Astrea. Up here, we have 3 Juno, and here we have 4 Vesta. So there are a number of asteroids that my software program keeps track of, but doesn't label. So I have to go in there and manually label it.
They're all previous planets.
You're kidding.
Yeah. When you can only see a dot and you don't know what it is, and you haven't invented spectroscopy, anything that moves is a planet.
Yep. Yeah, in the 1800s, these were considered planets.
Yeah. Okay, now this is the cluster.
That's it.
It's
Okay.
sort of a narrow field of view. This is it. Can you see it okay?
Yep.
Okay, it's got some, I picked this picture because it shows colors of stars. I don't see a conspicuous red giant in there, but there are some warm hues and some white cold hues. This is one that I would say is barely distinguishable from the background. It's not real tight. It's all, but you can pick out it's sort of a cluster. So that would be summed up in the Trumpler pattern. And I have to switch back to the other way of doing things because this one thinks I'm at the end of my pictures. So we're going to take a moment to change. Okay. Get rid of that.
Well, can I insert a
And
question in
then-
here while you're doing that?
Okay, go
Okay.
ahead.
Earlier you said if you were in this certain cluster, it would extend out to our nearby star, Alpha Centauri.
Alpha
And-
Centauri, the cluster itself is 2.2 light years in diameter.
So quite a
Okay,
bit larger, Ron.
Right, I understand then. So all the stars inside the cluster would be within light months of you then, wouldn't they? Or weeks?
No, 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 no.
Within-
This cluster is 20 something light years across.
Well, I'm talking about the earlier one.
That's what that's the same one we're talking about, Ron. That's the same one, 6709.
Yeah,
I thought you said it was only 4 light years across.
No.
I swear that's what I just heard you say. I was comparing it to the distance to our nearest neighbor, Alpha Centauri, which is
Yeah.
proximate with the earlier star cluster we were talking about would fit within that shell.
No,
Isn't that
no.
what
Ron, we're
Oh.
talking about the same one, 6709.
it's bigger. So if we, okay, got it.
He's saying the core radius is 2.2 light years.
Oh, the core
right.
radius.
The very, very
The
center.
total radius is 26.4 light years.
And they have a
Oh,
core
tidal radius.
tidal. Okay.
Yeah, the core, the bright core.
The tidal
Okay.
radius is kind of where the stars can escape more easily.
Well, they don't have a black hole in there like a galaxy, right?
No.
But there's a concentration of
No, this
stars.
does not have a black hole.
Hmm. Some of them do, you
Yes,
think?
it's a cluster.
Okay. What are we looking at here? Is that the
Some of what
core?
do.
This
That's
is
the
the
core.
BE star.
Oh, this is the BE star. Emissions.
This
That's the
is-
emissions on the left
This
and
is a
right.
star in the
No.
cluster.
That's the accretion disk.
Oh. Oh, it's got a disk. Stars can have
This is
disks.
the star, Achernar,
Achernar.
Achernar. It's an example. It's the brightest BE star. That is, it has emission lines in it. It's a hot blue star, and it has emission lines. And this is not in the cluster. This is an example of a BE star, and it's the brightest BE star in the sky.
Huh.
Rapid
And this-
rotator, obviously.
Yes, yes. If it were spinning any faster, it would be throwing off debris. And so it probably was bigger and was spinning faster and threw off its debris, and this is what's left. Because it's right at the limit. This is the Pleiades, obviously, which is another open cluster with nebulosity. So it'll have a little N after its classification. And this up here is the star Pleione. Pleione?
I think it's
Pleione?
And this is a
Pleione.
shell star. What's that?
I think it's Pleione. And Atlas is the one below it.
Pleione? Yeah. And so this is an example of a shell star, but it's not a shell star in 6709. These are just an example of a shell star somewhere else. And finally, this is the comparison of a red giant star in general, not any particular red giant star, compared to our solar type star.
Which is us in the lower right, right? Those are two red giants.
The solar type is this one.
Oh, I see.
This
Got it.
is the scale of 200 Earth radii here. This is the sun. This is the big red giant here.
So the larger picture is not to scale, Ron. The larger picture is just to show the interior structure.
Really?
Right.
Well, what's the smaller to
these
the
are-
left?
That's
Okay.
showing you the scale.
Oh. And would this be like Betelgeuse?
No, this is a red giant, so this is more like Arcturus or Aldebaran.
I
Not
have
Betelgeuse.
another question for you if you can handle this now or we can move on. But it's again from Richard. I think it was that, why is it that fusion takes it happens at the core? And I said because of the temperature is high enough to fuse hydrogen to helium. But he asked also, why do we say the electrons have been stripped away? That I don't understand.
Well, it's a plasma. The electrons aren't associated with the nuclei anymore. They're freely floating around.
It's so hot that the nuclear electrostatic force can't contain the electrons near the nucleus.
Yeah, they can't stay atoms in the middle of that mess.
Right. They're ripped apart.
But when the damn thing blows up, somehow we get all the atoms of elements above iron instantly.
No,
Don't we?
no.
We don't?
We get all the nuclei above iron.
Well,
Oh.
not all. I mean, some of those are
Yeah.
formed in neutron star collisions.
Huh.
I hope it answers it, Richard. It's again, it's be above me. These guys, that's why these guys are here.
Well, welcome aboard.
Okay, so here's the
let's move on.
structure of our sun and a red giant, and it shows their convective zone where the heat that's produced by fusion in here, where there's a burning shell, you get, and that's from there on in, you have temperatures and pressures high enough to slam nuclei together and make them stick in the core. And between there and the surface, heat conducts out through a convective process. All these little convective cells going up and boiling up and releasing the heat at the surface. And when the heat at the surface comes up, of course, all these moving of charges produce very complicated swirls of magnetic fields. And sometimes these magnetic fields come out of the surface and they grab bits of nuclei and electrons, not together in atoms, and throw them out into space. And once they cool off, then they can get together and form atoms. But even so, most of what gets to Earth as solar radiation, particulate radiation, is protons, unattached protons, that is hydrogen cores.
And it doesn't really show well in this diagram, but the difference between the sun and the red giant is that the red giant is almost wholly convective. Whereas in the sun, there's a radiative zone. And then beyond that is where you get the convection cells.
The light rays.
These things here, that's the convective cell there, and this is the convective cell here. And they're both represented as this series of bubbles or cells that are moving up, defined by heat. And you get these things when you're making spaghetti sauce in a skillet. You can see the convective cells from the hot skillet underneath coming up and spreading out on the surface.
Huh.
Okay.
What does convective mean?
It means it's bubbling.
Convective means transported by, let's say,
Physical motion,
you have you have a big crowd of people, but there's 10 people in one region where they're all teenagers and they're all friends and they all move together. That would be a convective cell. Because of the noise, they're moving away from the rock band on stage. So that would be a convective cell that's acoustically driven.
So the heat is being transported by these bubbles going up in a convective zone, whereas in the radiative zone, it's from free traveling radiation passing through the plasma.
Right.
But after, what is it,
And
millions
you might
of
ask
years?
yourself, how do you get radiation if you don't have electrons in an atom? And the reason is because a moving charge, an accelerating charge, radiates energy. So you have a lot of electrons in circular paths, and you have a lot of protons in circular paths, and either one of those will radiate Cherenkov radiation.
Well, can I ask a stupid question? Of course, inside these big balls of plasma are loose protons, which are positive, and electrons, which are negative, not together. Do they both contribute to the magnetic fields or just the electrons?
Absolutely, absolutely.
both of them.
Any moving charge will produce a magnetic field,
So, but
each of them.
I get the impression lately that protons are solid little things, but electrons are like little nebulous fields that aren't solid, aren't like a particle. Does that make sense? I guess not.
Well, Jerry's frozen for some
I didn't
reason.
hear what you said. I sort of lost.
Well, lately I've been hearing that the shell of an atom is just sort of a nebulous field, not really rotating particles called electrons.
Yeah, it's an orbital. It's not an orbit. It's a
Not an orbit.
probability distribution. So it's a
Okay.
shell.
But they're not the same as far as both particles. One just happens to be positive, and the other
Oh,
electrons
they
are
have different masses and they're made out of different things.
They
Why
both
don't
have
we-
wave properties, Ron. That's, I think, what's confusing you. But with a proton, it's less obvious.
Why aren't we streaming protons through wires to give us electricity here on our Earth? Protons are totally out of the equation. It's all electrons, isn't it? Gives us the word electricity.
Yes, that's right. That is correct. The protons are bound in the cores of the atoms in a wire, in say copper. And so the
Okay.
atoms all reach out and they hold hands with all their other copper buddies and they form a crystal structure and they're bound to that structure. They do not, to first order, they do not move, but they allow some of their electrons are far enough away from their atom, their parent atom, that they form a collective band and they belong to the whole crystal structure, not to a given atom. And so the electrons can move about freely and when you apply a voltage across it, they all rush to the exit.
Really? They don't hop, jump, and stop along the way on each proton, and don't light waves do
No,
that?
not the conduction electrons. Valence electrons do it. First of all, the
Okay.
electrons are what's binding the atoms to each other, the nuclei.
Well, that's a
You need
mystery.
a course in basic solid state physics, so next time.
Yeah,
Okay.
okay. I didn't mean to stray, but these are good stuff. I
That's
love this.
okay. We're looking now at for Vesta over here, moving through the sky.
The asteroid from hell.
Whoops. Okay. So Vesta is going to pass by in a very highly magnified view of this, which will not show on this planetarium thing, but there are some stars near Vesta and fainter stars too. I just cut off the magnitude that you can see. So they're near enough to Vesta that you can actually, over an hour, you can watch Vesta move past these stars. And so that's an interesting thing to do. And this is at about 10 o'clock tonight. So it could be if you're looking for something to watch that actually moves in the sky, that's it.
Is it
This
a
is
dwarf?
also in this region. In this region, there's a small globular cluster here, NGC 5634. And this one is believed to be a remnant of a Milky Way satellite galaxy.
A remnant of a Milky Way satellite, one of the the local group that we invited into the club here, huh?
Yeah.
Is
Yeah,
Vesta
and this is an amateur photograph.
okay? Meaning who took it? You? Well, you're not an amateur.
No, this is not from me. This is from Yu Han Kuo, which looks like a Korean name to me. It's a
Okay.
globular cluster, yeah. So that's a cool object that is with, it's an NGC number, so it's going to be slightly fainter than the Messier, but he doesn't give the size of the scope he used to capture, so I assume that it's going to be pretty easy for us to find it once you know where to look. And it's right here between Surma and whatever this star is up here.
Chuck will
Didn't get a
know.
name of that.
No, I don't know the name of it. It's going to be a Greek letter plus Virginis.
You'd have to
Yeah.
find out what our
There's the northern and southern, northern and southern claw.
Yeah.
Yeah, right there. So between the two, you make an equilateral triangle, and that roughly is where this small globular cluster is.
There's a lot of clusters in our universe or in our galaxy.
Yeah.
What do you suppose our friend in India is looking at this hour? Gets the same sky we do, doesn't he?
Pretty
He
much.
gets it, but
Yeah.
12 hours later.
Yeah, right.
Now, on July 31st, which is Thursday, toward the morning, before sunrise, looking southwest near Capricorn, from this radiant and around here, around Pegasus, near Saturn, Altair, Fomalhaut, you get, that's where you're going to see these things at a rate of about, what was it, 5 an hour or something?
Aquarius.
Yeah, the Southern Aquariid, Delta Aquariid.
Hmm.
Let's see if I can find the rate.
It's about a dozen per hour, it says in your output.
Okay. Every time I write these, I highlight things that I get to capture my attention when I'm trying to find it. I see I didn't capture this that way.
You did, but it says a dozen shower meteors per hour. So you're looking for a number, but you had a word there.
Oh, that's right. Yes.
Well, if there were a
Okay.
full moon, would it be less?
Yeah, you're right.
Well, the rate would still be the same, but the ones that you'd see would be a lot less.
Okay, and every one of these is remnants of a comet that came and went,
Yeah.
left
This
behind
one
it.
is Comet 96P Macholtz 1.
Fascinating.
So it's listed in the talking points. Now we have another one. So that's the morning of Thursday morning. Now we have an interesting topic. This is a composite, obviously. See how many pictures someone had to stitch together to get
Wow.
this wing of M31 at high resolution. And what they're looking for
Uh-oh.
in this square here is it
You're freezing occasionally,
Oops.
Jerry.
yeah. It looks to me like you guys are freezing, but I know it's really me. So anyway,
These are
these
globular
are
clusters around the
2,
Andromeda
3, 4,
galaxy.
5.
You were saying
Right.
this is a part of a what?
Well, go
These are
ahead.
globular clusters around the Andromeda galaxy.
Oh, okay, that's the big question. How many? We counted them? We can see them all?
I've seen
I
G1.
don't think you can count them all.
I've seen G1 pretty easily in an 18-inch. I don't know which one this is.
This picture shows 6 of them in the square.
Mhm.
Huh. So all those dots that we would call stars over in our galaxy are globular clusters in Andromeda
No,
galaxy.
not all of them. No.
Oh,
No. These are stars in Andromeda.
okay. Amazing. That's what, 2.5 billion light years away?
Million.
Million.
Oh, million, not a okay. I was using Carl Sagan's favorite, billion.
Actually, he
There
never
it is.
This is Mile 2 or G1. It's part of the Andromeda galaxy. It is a
Wow.
globular cluster that is believed to have a black hole in it.
Wow.
This is a cluster inside Andromeda?
Yeah.
Yes,
Orbiting Andromeda, yes.
orbiting Andromeda there. Yeah, even
Orbiting.
the clusters in our galaxy are not in our galaxy either. As Chuck points out, they're orbiting our galaxy
The globular clusters.
in not right globular clusters and not in the plane of the galaxy.
Really?
This cluster currently
Okay.
resides in Andromeda's outer reaches, which gives it a very good vantage point to see it without a lot of unrelated stars mingling in and around it. So this is a globular cluster orbiting the Andromeda galaxy, but outside the Andromeda galaxy from our point of view.
And the four spiked objects are stars in our galaxy?
Raindrops on your windshield.
Most likely,
Yeah, very likely, Ron.
Okay.
Yeah. Yeah.
So we're looking at some distance there in between those four stars. Wow.
those four stars, like you say, are in our galaxy.
Yeah, I know.
These are also globular clusters in M31 or orbiting M31. In is really wrong.
So I
But-
take it Jerry, the Mayall, it's probably the Mayall up on Kitt Peak. You know, the Mayalls were at Arizona, famous husband-wife team.
Oh, yeah.
Yeah, yeah.
hmm
What is that, Chuck? How many meters is that? 4 or 5?
I don't remember. It's big.
It's big. Yeah. When I was at Arizona, I went up and I actually looked at it, not through it. I just got to look at it. It's 4 or 5 meters. It's a big guy.
This picture is from the Sloan Digital Sky Survey picture, the background picture. These small pictures in the front were taken by an amateur in France, Robert Cazelac, and he's showing his results. What does he have? I think it's
16-inch, right, Jerry?
yeah, 16-inch Cassegrain by Zeiss. So he's got quite a nice observatory and dark skies.
Mm-hmm.
And we're looking at globular clusters in a distant galaxy, the big one, Andromeda.
Yeah,
Yes.
yeah.
But would it be fair to say if it has spikes, that's a star in our galaxy?
Very likely.
Yeah,
The
diffraction
upper,
spikes, that's ours.
the upper left. So you can't get spikes on those distant globulars?
They're not
They-
bright enough.
Right.
Is that what it
And
is?
if you take the picture long enough.
Ah. And they're orbiting around the galaxy. Okay, what is this?
This is the direct collapse black hole candidate.
Wow.
Oh, that's right. I did headline that earlier, didn't I? Ooh. So they're going around each other, making gravitational waves as I speak.
Well, no. These are two galaxies colliding.
Oh,
And the
I
bright
see.
yellow cores you see each have a supermassive black hole. But then that bright area in
Right.
between seems to be where colliding clouds of gas in those galaxies have reached a density where they collapse down into another black hole.
Wow.
So you're looking at 3 black holes.
Yeah.
Whoa, that's going to be a collision from hell when it happens.
You
May
know, it
have
almost,
already
when I look
happened,
at
who knows?
when I
What?
look at this in 2D, it looks like two concentric circles, but in another way, if I imagine it in 3 dimension, it almost looks like it's a bipolar explosion.
Or a dumbbell galaxy, or they're
This
Well, it's called the
actually is-
infinity galaxy because of that shape.
Oh,
it's like the 8. Yeah, the sideways 8. Well, they're both the same size. How far away is this sucker? Does anybody know? Did it say in the talking point? And that would be the Webb. The Webb took this picture, didn't it?
Yeah.
Wow.
It's got to be pretty far away, Ron.
Yeah.
Well,
maybe infinity.
Yeah.
but we're still looking at billions of years for all this to happen. It can't happen during our lifetime, can it? Thank God
Right.
again.
It happened a long time ago.
Yeah, it's true. It's happened in the past.
Everything
Wow.
you see in the sky, Ron, is past.
Well, I understand that, and
Now,
it
what's
makes it
reported in
hard.
the talking points is what's reported in the talking points is from a paper that is in peer review, so it hasn't been published yet.
Okay.
Really?
So,
Well, that's still a great
yeah, as
picture.
Chuck points out, this is called the Infinity Galaxy.
Yeah, because
Okay, go ahead.
the symbol. Yeah.
Suppose they have a big, huge coffee table book out with just pictures taken by Webb, including those 5
I'm
little
sure they
newly
will.
discovered. I bet they do. That'll be the Christmas gift, won't it? This is
Yeah,
great.
Timothy Ferris wrote one like that, Galaxies, about 20 years ago that I have on my coffee table.
Hmm.
Big
Is
pictures.
that right? Well,
Yeah.
that's great. Is there any more? Are we done? But got to consider the close, and this Friday night we're going to
Not
assemble
for
at
today.
Farron Hall. That's it for today.
Ron, you're saying Farron, but
Yeah.
the museum advertised it as being in Fleischmann.
Well, we'll have to see, won't we? Because they don't
Yeah.
always get it right. I got the word that we've been moved out of the big one into the little one. And certainly for how I did get a message from Owen in the publicity department that he put something by Martin Kakan, your godson's speech on the helicopter on Mars, on the website for the museum, if not YouTube, I'm not sure.
No, it was
Okay.
the museum gallery. Yeah.
All right. Well, let's do it again. Stephen Kane, UC Riverside professor of astronomy, going to take us exoplanets to exoplanet on habitability, including our own solar system. Could be in either hall. Just show up by 7, I guess. Until
Follow the
next
crowd.
week. Yeah, this is number 230. That's number 231 for August 4th. We'll start next Monday, a week from today. In the meantime, till we meet again, how do we say farewell in astronomy talk, Chuck?
Hasta Nebula.
Hasta nebula, everybody.